Good morning. Happy Thursday. It is the Thursday before the holiday break. We've got gingerbread houses along the back hanging up here, our little snowflakes, and it is cozy day for me here at school. That's why I'm in my pajamas, which is always a great day. So we have a lot of fun things planned, but in today's video, I really wanted to share just some of the subtraction strategies we have been teaching students. We are finishing up our subtraction and addition within 20 unit, and I made a little anchor chart of the strategies we have taught so far. So I just wanted to share what those strategies are, kind of how we led up to this point, and then also some of my favorite activities for having students practice subtraction. So that's the plan for today. Here is the anchor chart we have, subtraction strategies. I have 6 different strategies that we really focus on, and it is set up in a similar way to my addition strategies one over in the back. So the first 2 we have are I can use cubes and I can draw pictures. Now, we first start teaching subtraction within 10, and we did that actually like a month or 2 ago. So we have already introduced using cubes and drawing pictures, so I didn't spend too much time going over this, but as we dove into this unit where we are subtracting with larger numbers up to 20, I just let students know you could use the same exact thing, right? So we really practice that hands-on practice first, where 12 minus 4 means I'm gonna grab 12 cubes, I'm gonna subtract 4, and we have 8 left, so that you can actually have all of them, give some away, this physical act of building and removing. So some of the activities I show you are going to be just like this. They're in that concrete kind of part of teaching students subtraction, where they are really feeling the number, getting rid of some, and then figuring out the difference. The same thing happens when we go to drawing pictures. This is obviously a pictorial or representation of the number, but students get that physical act of drawing that many circles out or shapes, whatever, and then physically crossing them out and getting rid of them allows us to see the leftovers. So again, this kind of act of I have something and I'm giving something away. Now, we know that this kind of building and removing is not the only type of subtraction we have our students do, and it's not the only time we actually use subtraction as an operation. For instance, comparing numbers, finding the difference that way. But this is how I always like to start, because when my students come into first grade, I don't know about yours, but some of them even have a hard time realizing like, oh, this number is getting smaller, or we're going backwards. They're just so used to adding as their like primary form of math and operation. So I really like to make it note that when we see that subtraction sign, we're giving things away. We are getting smaller. So we start there with cubes and pictures. One of my favorite hands-on activities for teaching students how to subtract is just called build and remove. I have done this forever. It's actually in my hands-on subtraction unit where I go over a bunch of different strategies. I think I made that in like 2017 or something. But I first do this with subtraction within 10. So the sheets I have are slightly different, but I want to show you just the 2 of them and kind of how they work. It is a very simple process, you can see, that you could easily replicate. So let me show you. This is the build and remove mat from my whole group teaching slides. And this is when we are first teaching and introducing subtraction. So it only is within 10. But I was just thinking, because I have this other mat that I'm going to show you for within 20 that has the double, because it's within 20, so it has 2 tens frames, but I think I could make something similar. I'll think about it. But anyway, so here all students do is I laminate these or I put them in plastic sleeves, and then they spin this to see what they'll build. So let's pretend they land on 7. Grab 7 cubes. I don't think I really even need to show you how to do it, but you know, just for fun here. 7 cubes, boom, and remove, spin 2. And they have to write down 7 minus 2 equals 5. As you can see, extremely hands-on. So students play this a lot so they can get used to, again, that building and removing. We have some and we're taking some away. We're getting smaller for subtraction. And I like that they have to write the equation here. Then as we fast forward to subtraction within 20, I have these Let's Subtract mats. I do have a bunch of these that are laminated along with these cards, and I couldn't find them and I didn't feel like spending a bunch of time finding them right now. So instead I just printed out a copy of one, but this is the Let's Subtract mat. I have cards just like this. It says build and add that are completely free when doing addition. I can link them down below. But again, this one is in my hands-on subtraction unit. And what they do is they simply get these cards. I have them all laminated so they can be reused over and over as a little center. And then it says build 19. So I'm not going to build them with all the cubes, but they build 19. And then they have to remove, physically take away 9 and find out what the difference is. So what is the difference? 10. Then they have another one. Build 9, remove 5. So this one has cards that are all up to 20, build 11, remove 7, and build 14, remove 10. And we could even extend this. If this is laminated, I can have them write down the subtraction equation here at the bottom. So that type of game is by far my favorite for teaching students how to use cubes, how to use those manipulatives. Again, getting them used to actually building something and then taking something away. We are removing it. Now, the next step that I like to teach students, the next strategy is to draw pictures. To do that, I typically just like to show students on the board that another strategy, if I don't want to go grab cubes, I can quickly draw like 11 circles and I can cross out 4 of them to see. This is going to get students to really take a look at that subtraction equation and get them to understand what those numbers are. So if it says 11 minus 4, we are starting with 11. I need them to draw 11 circles. Taking away 4 means I'm going to cross them out. I don't want them there anymore. I want to see that they are gone. And for something like this, I would simply have my students take out their whiteboards and markers, and I would just on the board spin a spinner, anything that's higher, maybe number 7 all the way to 20. I would spin a spinner. They would write down whatever we land on, let's say 14. And then I would roll a die to see how many they're going to remove. Just, it'll only be numbers within 6, but with the different spinner, you'll get a bunch of different equations. And then once I roll the big die, they see, okay, 14, let's say, minus 6. They're going to draw 14, take away 6, and then they can also write the equation on their whiteboards. So that's a very simple way to practice it. Both of those strategies for within 20, I only spend 1 day on. I could probably combine the day, but those 2 strategies do get used a lot, and for my students that really need that hands-on practice, I like to get them a full day of that. I would do it longer when I'm teaching subtraction within 10 for that first unit, a month or 2 ago. We definitely use manipulatives a lot longer. But for this, we kind of review it for 1 day, review drawing pictures for 1 day, and then we move on to trickier strategies. So those are some of my favorite activities for really providing that hands-on practice with using cubes and then drawing pictures. And basically with each subtraction strategy that we teach students, I do a whole group lesson on it. I explain how it works. I model it. We practice it a little bit. And then we kind of introduce a new one the next day. The goal isn't necessarily for students to master it that day, but instead, as we add to our subtraction strategies anchor chart and as we continue practicing subtraction, the goal is for students to find not only what strategy works best for them, but also which strategy is best for that problem, which is something that they're going to gain throughout the year. So really we're kind of, again, throwing those strategies at them, teaching them explicitly how and when to use them, and then having students practice that with review. So we always start with that concrete hands-on practice. We move to our representational where they're drawing pictures, and then we move to that abstract. And the abstract is just going to be that basic fact practice, right? We're working on that fact fluency, especially in first grade with those numbers within 20. And one of my favorite ways for students to practice fact fluency is with IXL. I am thrilled to be partnering with IXL in today's video because it is a program that my students use every single day here in first grade. In case you don't know, IXL is an online program for kids in grades K through 12, and it has tons of skills, lessons, and activities that teachers can easily assign to students right away. Typically, towards the end of a lesson, after we've practiced the skill in whole group and together, I will send students off. They might do a paper and pencil activity, but then I also like to have them go on IXL to complete some independent activities, and this allows me to really see where they're at. Let me show you what IXL has for subtraction. Once I get into IXL, my favorite thing to do is to go to the textbooks tab, because here I can actually look up the exact chapter and skills we are working on with our curriculum, Math in Focus. We are currently in chapter 5, and some of these subtraction strategies here are ones I plan on using. So I'm going to use this one right here, subtract by counting back. I'm going to go ahead and star that. And I'm also going to do this one down here, addition and subtraction sentences to 20. They have to look at them and determine which one is true. So I'm going to star those. After my students go ahead and work through these and they get a score of 100, they are allowed to play games. And right now, let me show you the game my students are loving. The game my students are loving right now is a Fuzzbugs Factory Hop, where students have to try to get to the top, and then when they get to the top, they have to answer some sort of question. Once they make it to the top, they have to answer a question like this: how many is 4 less? So they look at these blocks here, 1, 2, 3, 4, 5, 6. 4 less would be 2. If they get it correct, they get to keep playing. If you want to try out IXL with your own students or kids at home, they're actually offering a 30-day free trial for teachers and an exclusive 25% off for parents at home. Whether you're a teacher or a parent, you can take advantage of all of IXL's core subjects like science, math, reading, language arts. You can do that all just by checking out the link down in my description. All right, so as for some other strategies that we teach using a number line, counting back, making 10, and using addition. So I'm gonna quickly just share using a number line and counting back. Those are kind of our middle level strategies that I teach students. And really, if you notice, they're both actually counting back. One, we're trying to get them to do it in their head, and the other, they're actually using a physical number line. And these two are going to be more advanced. So let's talk about the middle two. For a number line, again, this is just a 1 day type of strategy that we teach, and students do get it pretty quickly. The trickiest part about a number line is making sure that they don't, when they do that first hop, they don't say 1 until they've already made the hop. And I actually have a whole video about using number lines or teaching math with number lines, I believe. Or at least if it's not a whole video, I have a whole portion where I talk about this. And the biggest thing, if you find that your students are having trouble with an actual number line like this one, where, they're really just kind of measuring distance, instead I would use number tape. And a number tape looks like this. But here they can physically see each number, and each number is basically represented by a block. It'd be kind of like if we had a bunch of cubes lined up. And that's just an easier way for them to see that hop than this. So that is typically, if you have any students struggling with that, I go right to a number tape. Before they have to do the number line. Now, in terms of teaching this lesson, there's nothing really special I do other than put a big number line on the board, and I show them how we start at the bigger number. We are subtracting, so are we getting smaller or bigger? We talk about which way we're going, and then I teach them the actual procedure of hopping back that many spaces, and again, filling out the equation down below. Now, just to make sure I say this out loud, after I teach students a strategy and I put it up on the board and I model how to do it, I always then, I do, we do, you do. So then I send them off to go practice it with a partner. So when I mentioned the picture one where we're drawing pictures, that would be our we do. We kind of all do it together. Maybe I'd have them sit next to a partner to check, but then I would go send them off and they would do some sort of independent practice subtraction sheet, or they would do something on IXL where they could practice that strategy, and I would give them a paper and pencil. Same with our number line. So with a number line, after I show students how to use it, we have these double-sided number lines. And again, we did teach this within 10 first. So this is kind of a review lesson for them, but I would give every student one of these, or I could even pair them up and have them kind of go back and forth. And I would put a subtraction equation on the board. I usually put like 3 or 4 of them, and then we talk about how to do it. I watch them practice do it. That way I can go around and just assess real quick and see who needs extra help, who I can pull back with me during that independent time, and who is getting it. So after they practice a few by themselves, I have them do a little practice sheet. Here's an example of a practice sheet I have in that hands-on subtraction unit. We just have a little number line up here for them that they can reuse. And again, these numbers are within 20, so they'll just start, hop back, and answer them. I also like that this one, they are vertical instead of horizontal. We do a lot of horizontal practice, and I like to show students that both of these are ways of showing the equation, and that we have our equal sign. It looks a little bit different here. All right, moving on to counting back. This is where I tell students this is another way we can count back. Instead of using a number line, we can actually put that number in our head and we can count back the number we are subtracting. Now, this is something we teach when we are teaching addition, so they're used to putting it in their head and counting on. But that act of counting back isn't as natural for them. So before I do this lesson, or for our warm-up for this lesson, we always practice counting back, like just circle counting. We count back. I might say, I'll literally have us sit in a circle. I'll point to a student and I'll say, count backwards from 15, go. 15, 14, 13, 12, 11, and we have to get to 0. And then I'll pick another student from 20, go. From 19, go. And then I'll pair students up and just say, starting at 20, count back as fast as you can, back and forth, just to get them more fluent with counting backwards. So we always start there. And then again, just like the pictures, just like the number line, I explain, we look at an equation. If it says 15 minus 3, I tell them, okay, we put that number in our head, 15. How many are we counting back? We're getting rid of 3, so we're gonna go back 3. 14, 13, 12. 15 minus 3 equals 12. So just again, that practice. Now, A tip that I like to give, and I do this for counting on too, a tip that I like to give is if students are having trouble with their fingers or putting it in their head, I have them draw dots when they're counting back, and then I have them practice on a little sheet like this. So let me show you what that dot strategy looks like. Okay, so for counting back, and again, I explicitly show them how to do this on the board, is 17 minus 8. I say, okay, we're putting 17 in our head. We're going to count back 8. That might be hard for me to remember because that's a lot to count back. Maybe I will draw dots. So I'm going to draw 8 dots. 3, 4, 5, 6, 7, 8. And then I'm going to count back, and I can even cross them out as I go to make sure I don't lose my spot, or I can write down. The writing down's a little harder. This is kind of how I show them. Like if I wrote 16, 15, 14, they can lose track, and it just is a slower process, so I really only do this if necessary. But instead, I would say 17. Okay, we're counting back 8. I already have our dots here. 16, 15, 14, 13, 12, 11, 10, 9. Our answer is 9. 10 minus 6. We're going to draw our 6 dots. Now, hopefully they would already know this one as a tens fact, but we would count back 9, 8, 7, 6, 5, 4. 4. So they can practice like this. Again, this is from that hands-on packet because when I teach them a strategy, I have a little anchor chart for it. I show them how to do it, and then I have them practice after we do it together. All right, walking back over to our strategies chart here, we have our 2 trickiest ones, which is I can make 10 and I can use addition. Now, if you watched last week's video, I talked about this one a little bit. It is a doozy, but what I love about this is it really teaches students that we can decompose. So most of my students do not master this the first time, and that's okay, but it does teach them that we can decompose these numbers. So as you can see here, let me bend down, try not to hurt my knees. 16 minus 7. I can take this 16 and I can break it into some smaller numbers that might be easier for me to subtract. So I can break this into a 10 and a 6. Then I know that 10's fact, right? 10 minus 7 is 3. And then what do we have left? We have to add our pieces back together to make 9. Like I said, very tricky. I typically try to show them this using maybe a little bit of a number bond. And I definitely use cubes for this. Again, tricky. I explain it. Really, if I'm being entirely honest, only my highest couple of students really understand how this one works. But we do teach it. And I do very much love this word, decompose. We talk about it all the time. And this is really where I'm looking for my students to decompose these numbers. And they grow with that all year long, especially as we head into double-digit addition. Okay, I went over to my computer just to pull up the slides for when we taught this day. And we started by basically reviewing how we break teen numbers into 10s and 1s, which we just did in our last unit. So this was just a good little start. We have our part whole here. So 14 is 10 and 4. 13 is 10 and 3. So we started with that right there. Then we talked this problem through, and I did this with cubes to kind of show them. So Samuel makes 12 stars and he gives 7 to Amira. How many does he have left? I could quickly group these into 10 and 2, and I do this with cubes. And then I say, okay, well, I cannot subtract 7 from these 2 over here, but I can subtract it from the 10. So on the board, it showed us cross out, but in my group, I would actually take away the 7 cubes. Then we have 3 left over, and we have to put our 3 left with these 2 because we never touched them, right? They're still there, and our answer is 5. So really, it's just getting them to see that they can take away that smaller number from the 10 instead of the full 12 because we can decompose it, and it's the same. Easy, right? So simple, so simple. Okay, the last strategy we have is using addition, and this is where we get to come back around and talk about fact families and just really that relationship using number bonds between part, whole, how these numbers are all connected. Addition and subtraction are connected as reverse operations, all the fun stuff. This one is a lot easier for my students to get than the making 10. So let me just show you this part of the strategy chart. Oh wait, before I show you that part of the strategy chart, I did forget to say, when we talk about making 10 and we do that lesson, I don't give my students a full practice sheet to do independently in that way. We do that completely together, whole group. And then when I give them a practice sheet to do independently or some sort of independent practice, I just give them some basic subtraction within 20 and I tell them they can use any strategy. Then I will pull small groups and kind of work on it a little bit further, but I don't expect them to go do that independently on that day. All right, now let me flip it. Okay, last one. I can use addition to help us subtract. 18 minus 9 equals. If I see 18 minus 9, I'm also saying 9 plus what equals 18. And that right there, my friends, is a doubles fact. So if I represent this as a number bond, then I can quickly see what that number is. When I'm teaching that to students, I am starting with my warm-up of just a fact family. I am reminding students what that is, how these numbers are connected, and I have a couple students come up to the board and they actually, I have a big house up there, and they actually fill in the fact family first. And then I say, hey, we're gonna see how this can help us actually subtract. We're gonna see how just knowing these number relationships can help us subtract more quickly. All right, so I went over to the slides again just so you can see kind of what we talked about, but it basically says you can make a fact family from an addition sentence. So if we see this addition sentence right here, 7 plus 4 equals 11. So if I know that, there are actually 3 other equations that I also know. I know 4 plus 7 equals 11. I know 11 minus 7 equals 4. I know 11 minus 4 equals 7. And then I showed them that we can do the same thing when we subtract, or when we have a subtraction sentence. Because I know 13 minus 8 equals 5, I also know all these other things. And then we try to practice, right? So there are 12 deer, 8 of the deer are drinking from the pond, how many are not? So there are so many ways we could solve that with our other strategies, but we're gonna practice using what we know about addition. So we go ahead and fill in, I think this was a blank at first, and then we said, okay, so we know 12 is the whole, 8 is one part, what's the other part? And we figure that out. Same here, if we have the missing whole, right? If we're starting here, we have the missing whole. Here's a word problem. How can we figure out what we started with? We know that 4 plus 9 is a related fact, so 13 minus 4 must equal 9. And then this was the activity that they did. They basically just took 2 dice and some cubes. They would roll them and then go ahead and make fact families. We've done this before. I didn't do this exact one. I did it from my fact family math teaching slides that they have practiced before. So we did that together and then we practiced. So this is what the practice looks like. We did this largely together, and then I have another practice sheet that I'll show you that we did independently. Again, these are our trickier strategies, so we do spend a little more time on them, both during the actual teaching of the lesson and then also in small group as we continue to review our subtraction. If my students have already mastered the other 4, like of course, if my students still can't do it with cubes, I'm not focusing on this yet. If they can't do it with pictures, I'm not focusing on this yet. We walk through the concrete to the pictorial to the abstract, and this is just a more difficult strategy. So then once students have gone over that strategy, I will just give them a subtraction problem like 13 minus 4, and I will have them fill out a number bond or a part whole chart just to show what that is showing. 13's our whole, 4 is one of the parts. What is that other part there? And then again, we practice filling out a fact family. Then, just like with the I make 10, I will give them for an independent sheet, I will largely give them a, just a basic subtraction sheet, and they can go ahead and practice all different strategies they've used and see how they're doing with it. Now I just wanted to show you a couple of the games we've been playing before I end this video. So a couple of the games we've been playing to just kind of review and reinforce all these strategies throughout these past couple weeks. Now, these are going to be just from my print and play subtraction games. This one is pretty simple. It's called Fill the Balloon, and they work with a partner to fill the balloon. So they just roll 4, 1, 2, 3, 4, 12 minus 2. They can use any strategy they want to find the difference of 12 minus 2, and they'll color in their 10 with their color balloon, their color crayon. Then next person goes 2, boom, boom, 9 minus 6. Whatever they know, go ahead, color it in. Keep going, back and forth. 1, 2. 9 minus 2 again. Oh, this was 9 minus 6, just kidding. 9 minus 2. Whatever the answer is, 7, color it in. Back and forth and back and forth. All different problems. They can use any strategy they want. And again, they're just trying to fill in this balloon. Another simple one I love from this pack is fill the spaces. I have this game for free for the 10 version, and we practice this a lot. Again, just getting them to understand those tens facts. So for this, I let students know they roll 1 dice. That's why there's 1 dice up here. And they subtract it from 10. So 10 minus 4. 10 minus 4 is 6. They would fill in a 6 here. Next person goes. 10 minus 4. 10 minus 4 is still 6. Fill in a 6. 10 minus 3, 7. Fill in a 7. And they work back and forth and they try to fill in all the spaces on this page, which means, since they already know how to play that, because we did it before, same thing, but with 20 and with 2 dice. So here they are always starting at 20. 20 minus 2 plus 3 is 5. 20 minus 5, 15. Fill in the space. 20 minus 6, 14. Fill in the space. You get it. So like I said, I have this free one down below. This is just a great game for students to work on their fluency with this and get them used to that anchor number of 10. And then this is just the extended version. And last but not least, we have spin and subtract 5 in a row. This is version C. I believe A only has numbers to 10, and then B has teen numbers. This was the higher teen number, so there's 3 of these. And very simply, students will spin this here, and then whatever they land on, let's say 17, they will subtract the 1 die. 17 minus 5. So this way they are subtracting higher numbers, but it's not always from 20. So I do start with this one first. And then we have different equations here. So 17 minus 5 is 12. I can color it in, or you can just place a cube. And here, instead of coloring in the whole grid, students are looking to get 5 in a row. On top of all of those print and play games, don't get me wrong, I still have more, because these games are typically ones that I will play during the actual math block after they have, like this might be a game that, like I said, they do together where they are doing the we do part, and then they go to an independent practice, or I might have them do this through independent practice just to keep practicing. And then these are what I use on review days and during WIN. So just to show you real quick, these are my subtraction within 20. These are different than my subtraction within 10. Some of the games are the same, but of course they are within 20 instead of within 10. So subtract and clip. Here they just have to find all the equations that equal the number in the middle. Bunny Hops has them using the number line there to solve the problem. So you can see some different strategies we have here. Count and cross out, of course, is going to be using that pictorial one. So they are starting with that top one. This one here is a misprint, just so you know. There are actually only 11. And then they cross out 8. So using pictures. Here we have a true or false with the 20 frames down below, the 2 tens frames, so they can actually draw it in and see. So 12 minus 8 equals 4. Is that true or is it false? Circle it and show it down here. Missing parts. This is going to be that one that uses addition. This helps us with our fact families. 14, here we have the missing part. So 14, 7, we solve for the missing part. And then we show an addition and a subtraction sentence you can make from that. And we have eating cookies, and this is going to be our hands-on one. You can use Play-Doh, you can use cubes. It's not going to fit on the tray here. You can also just have them draw pictures, but I tell them if they want to represent the cookies with cubes, they can. So they can take out 16 cookies, take away 5, write down the answer. So all the different strategies are still being practiced during those other times with our task cards. Okay, and then really, last but not least, but we just did this one yesterday and students really liked it, and it was a great extension because what we did is we taught all the addition strategies first, practiced that for a couple weeks. We just did all the subtraction ones over here for a couple weeks and practiced them, but we always want to bring it back and review all of them at a time to see how they're related. So what we did is we talked about balanced equations, and how, 13 minus 4 is the same as 5 plus 4, right? They both equal 9. There we go. So all I did is I printed out 18 cards here, and there's just 9 matches, and students had to turn them around, lay them all out, just like you do with memory, flip over one at a time. 15 minus 3, they had to solve it, is 12. And then they had to flip over another card, solve it, and they're looking for the matching addition equation. So a lot of work there, but it was a really good game for students to get used to just solving quickly and then also seeing that relationship between addition and subtraction. All right, I know there's probably a million other games and other things you can do, but I think this video gave you plenty of ideas for teaching subtraction within 20. As always, I hope you enjoyed this video and found it useful. Maybe you can take away 1 or 2 things. Maybe you've done these things before and then you forget about them. That happens to me all the time. I've taught some of these strategies in games, 11, 12 years ago, and I'm like looking for something new, or I'm looking just, how do I teach this? And then I'm like, this is my own thing that I did a long time ago. I remember. So sometimes I just need a little jog of the memory. I don't know if that happens to you. But as always, if you enjoyed this video, please give it a thumbs up so I know. Make sure you are subscribed to my channel and click that bell. That way you're notified of every new video. See you in the next one. Bye. Thank you.